Welcome to the training module on the LM315 Synchronous Simple Switcher controller. In this module, we will discuss the features, application, and performance characteristics of the LM315x device. We will also go over block diagrams, examples of schematics, and the eval board. The LM315 Simple Switcher controller is an easy-to-use and simplified step-down power controller capable of providing up to 12 amps of output current in a typical application. Operating with an input voltage range of 6 to 42 volts, the LM315 features an adjustable output voltage down to 0.6 volts. The switching frequency is adjustable up to 1 MHz, and the synchronous architecture provides for highly efficient designs. The LM315 controller employs a constant on-time architecture with a proprietary emulated ripple mode control that allows for the use of low ESR output capacitors, which reduces overall solution size and output voltage ripple. The constant on-time regulation architecture allows for fast transient response and requires no loop compensation, which reduces external component count and reduces design complexity. This device can go into various application areas like telecom, networking equipment, routers, security surveillance, and power modules. This chart lists the key performance specifications of the LM315 device. The device can deliver a maximum current output of 12 amps, a max input voltage of 42 volts, a max operating frequency of 1 MHz, and with a 95% of efficiency. The LM315 Synchronous Step-Down Simple Switcher controller uses a constant on-time architecture, which is a derivative of the hysteretic control scheme. COT relies on fixed switch on-time to regulate the output. The on-time of the high-side switch can be set manually by adjusting the size of an external resistor. To maintain a relatively constant switching frequency as Vin varies, the LM315 automatically adjusts the on-time inversely with the input voltage, assuming an ideal system and Vin is much greater than 1 volt. Control is based on the comparator and the on-timer, with the output voltage feedback compared with an internal reference of 0.6 volts. If the FB level is below the reference, the high side switch is turned on for a fixed time, which is determined by the input voltage and the resistor. Following the on-time, the switch remains off for a minimum of off-time, as specified in the electrical characteristics table, or until the FB pin voltage is below the reference. Then the switch turns on again for another on-time period. The switching will continue in this fashion to maintain regulation. During continuous conduction mode, the switching frequency ideally depends on duty cycle and on-time only. When the output voltage is below the comparator's low voltage threshold, the power stage turns on. The duration of this on-time pulse is a function of how long the output voltage stays below the threshold. As a result, the pulse frequency is not constant, but depends on how the output voltage changes during both the on-time and off-time. Hysteretic control does not require an internal oscillator. Switching frequency depends on the external components and the operating conditions such as load current and line voltage, since these parameters influence when the output voltage crosses the hysteric comparator threshold. Constant on-time control minimizes the change in switching frequency with line variations, which, depending on the particular hysteretic design, would otherwise vary the switching frequency significantly and create many problems. Constant on-time control sets a fixed on-time which is influenced by input voltage. The on-time becomes inversely proportional to the input voltage. With this feed-forward correction of line variations, the switching frequency will not have to change, and as such, the simple relationship of duty cycle to input and output voltage is retained. This slide shows you the typical MOSFET gate charge curve, which is obtained by considering the proper component value for R sublimit and RDS(on). The gate drive current from VCC must not exceed the minimum current limit of VCC. The design guide provides the equations required to design with the LM315 Simple Switcher controller. The Web Bench Design tool can be used with or in place of this section. We have given the steps for how to design with LM315 device. The available frequency range for a given input voltage range is determined by the duty cycle, or Vout divided by Vin, and the minimum on-time and off-time. This is a typical performance characteristics of the device family. The first graph shows the efficiency versus load curve at 250 kHz, and the second shows it at 500 kHz. The LM315 evaluation boards are designed to provide the design engineer with a fully functional power converter based on constant on-time and with emulated ripple mode control to evaluate the LM315 and the entire LM315x family of parts. The evaluation board is pre-configured to use the LM315 with the output voltage preset to 3.3 volts and a typical max load current of 10 amps. There are 3 different boards that are configured for 250 kHz, 500 kHz, and 750 kHz respectively. The eval boards allow for a variety of configurations, and in this multifunctional capability is used to also accept the fixed output versions of the LM315, such as LM315-3.3, LM315-3.3, and the LM315-3.3.